All right, okay, big day today, awesome day today, fun day today. Yeah, raise your hand if you're excited. All right, raise your hand if you're not using Snapchat during class today. All right, way to go. Way to do what's difficult, folks. I'm very proud of you, very proud of you. Okay? If you could keep Trey quiet in back of class, appreciate it. Thank you. All right. So today we start with Sohcahtoah. So, excellent. My good friend Hannah, she says, I remember this. This should kind of kick in. Had a few people, they said, I said a scale 1 to 10. How well do you remember this? They're like a 2. Other people said 8. Obviously, if you're a 2, it's going to be a little bit tougher. If you're an 8, it's going to be just fine. So, take a triangle, and Sohcahtoah works with a right triangle. And what we do is we identify an angle as theta. And then we identify the 3 sides of the triangle as either the opposite side, the adjacent side, or the hypotenuse. So I'm going to go to this one right here. Everybody know what this is? This is the hypotenuse. The hypotenuse is always across from the 90-degree angle, 100% of the time. You all good? HYP. Hype. Hype. All right. And then anybody know which one the opposite is? The one on the bottom or one on which one is it? Why? Because it's opposite the angle. We're talking about this angle. Laura is 100% correct. Point at Laura and say smart. Smart. Okay, so this is the opposite side if we're referring to this angle. If we were talking about the angle up here, then the bottom one would be the opposite side. So it depends on which angle you were talking about. Everybody see that? So, if I asked you who is sitting adjacent to Hannah, who would you say? Because that means next to. So if I draw the angle, which side is next to the angle? And it would be this side. That's why it's adjacent. It's next to the angle. So that's why we use the words that we come up with. Now, your geometry teachers explain that to you. You maybe don't remember it as well, but identifying opposite adjacent hypotenuse is the first step. And then we say that sine is SOH, S-O-H. So sine is the opposite divided by the hypotenuse. Opposite over hypotenuse is sine. Yes, but we just skip them all. We don't use those other 3 in Sohcahtoah. I have them there cross off. People usually get, like they're like happy when they get to cross them off. So. Cosine is the adjacent divided by the hypotenuse. Tangent is opposite over adjacent. Thank you, Easton. And that is that. Now, for me, when I was in high school, never learned Sohcahtoah. So you're like, well, how did you do trigonometry, Mr. Gens? Very easy. I learned that sine was y over r. And cosine was x over r. And tangent was y over x. I just always drew my triangle. I used x, y, and r. My point? You don't like it. Got it. That's all right. Teach your own. Find the exact values of 6. No, let's not do 6. Let's do 3 trigonometric ratios of the angle theta in the triangle below. So we want to determine sine of theta, cosine of theta, and tangent of theta. Ooh, boy, oh boy. Need to first label opposite, adjacent, and hypotenuse. Which side is 5? Opposite. Which side is 13? Hypotenuse, and then this one down here is adjacent, which we don't know. Sine is the opposite divided by? Hypotenuse, so it'd be 5 over 13. In order to find cosine, I would need the adjacent over the hypotenuse. We don't have the adjacent. How could we ever figure out the adjacent? Yes. A squared plus b squared is c squared. So 5 squared plus b squared is 13 squared. Or 25 plus b squared is 169. b squared is 144. So b is 12. So maybe some of you recalled that this is a 5, 12, 13 right triangle. Anybody remember that that makes a right triangle? It's a Pythagorean triple. See four heads nodding, everybody else shaking. It's true that 3, 4, 5 is also a Pythagorean triple. Maybe you recall that 8, 15, 17 also is. Maybe recall that 7, 24, 25 also is. And it keeps on going. There's a lot of them. But it also is true that any multiples of those also work. So for example, if 3, 4, 5 works, then so does 6, 8, 10. So remembering those is helpful, without a doubt. I would say come ACT time, it could really save you some time. They love to use the Pythagorean triples on the ACT. And now you see them. There's a review. Here we go. Tangent. What's tangent? 5 over 12. Good. So look at the next triangle. This is my angle right here. Okay. What I want you to do is two things. I want you to take about a minute. I want you to find this missing side over here. We'll call it C. And I'd also like you to label the triangle as opposite, adjacent, and hypotenuse. Ready, set, go. Work with a partner if you need to. 4, 3, 2, 1, and done. What is the length of the hypotenuse? 4.47. 4.47. Can somebody tell me in simplest radical form? 2 root of 5. Very good. So I think most people saw that that's the hypotenuse. What is length 4? Is that the opposite or adjacent?
4 is the opposite.
Are you sure? Positive? You're right. Yep. You go right across from the angle and you get that. Jason is right there. Good job. So we have sine of theta is going to be, so I go 4 over 2 roots of 5. Oh boy. So I got 2 over the root of 5. Am I good now? No. So we got 2 roots of 5 over 5. I know most people don't like the way that looks, but...
Is that right?
Yeah.
Can you explain how you did that, though?
This step?
Yeah. No, because I get that you, like, times it by the square root of 5, but then do you bring the 2 with it? Because you can't separate, like, the 2 and the root of 5. Right?
Yes. Yep. So, yep, just multiply top and bottom by root of 5. 2 comes later on. Yep. Cosine is going to be 2 over 2 roots of 5. You can see that the 2's cancel. Or I should say they divide and give us 1. 1 over the root of 5. Root of 5 over 5. How about tangent? Dos, which is Spanish for 2. What up, Easton?
So, I know, like, for the second triangle, finding the opposite was easy enough. How are you supposed to figure out which is the adjacent and which is the hypotenuse? There's no right angle to really help out.
The hypotenuse will always be opposite the right angle.
So there's always will be a right angle, that's why we wouldn't be doing
You can't do Sohcahtoah without a right angle. Must have a right triangle in order to use Sohcahtoah.
So only evil people would put that on, would put non-right angle on a text.
No. We spend 1 day on right triangles, which is today. We spend a whole unit on non-right triangles that we try to solve. That's where we'll get.
And basically we take this entire day and just throw in the trash.
Can't. Well, no, not exactly.
Solve that. Non-right triangle.
It's just a little bit different. It's fun. It's actually
Give us a non-right triangle.
well, there's a lot of them that exist in the world. We want to know what to do with them. Okay, here we go. Turn to your worksheet.
I don't want to live in a life without art.
Imagine life without math. How sad it would be. We would sit around and read poetry the whole time. It would be like if the world didn't have math, it would be like Hamlet. Like, how bad would that be? You know what I mean? Oh, good times. Hey, stop that! I'm trying to be funny. Yeah, whatever. All right. I would like to go to problem number 1. We're going to give you a little bit of time to work, and we're going to solve some problems together. Are you ready? Here we go. We want to find the missing side. So what I do is I look and I see, I want to solve triangles. That's my goal for today. So we learn a little bit about Sohcahtoah. I got a 37-degree angle. I've got x, and I've got 11. What side is x? Opposite, adjacent, or hypotenuse? Hypotenuse. So says Mr. Positivity. How about this one over here? Adjacent. Do you agree that this is the opposite? And it does not matter, does it? Like, we don't need to even consider the opposite side because we're not trying to find it and we're not given it. So if I want to find x, I am looking for the hypotenuse and I'm given the adjacent. Which trig function do you think you will use? Cosine, exactly. If we look at Sohcahtoah, then you're given the adjacent, you're looking for the hypotenuse, that tells us we use cosine. So we set up cosine of 37 degrees is equal to, and this tells us how to set it up. You have to take the adjacent side, which is 11, and you divide it by the hypotenuse, which is x. I would encourage you at this point to write it over 1 and to cross multiply. As I cross multiply, I get 11 is equal to x cosine of 37. How do I solve for x? Divide both sides by cosine 37. And a lot of times this is how they leave it on the ACT or MCA. So we're going to leave it as x equals 11 over cosine 37. 11 divided by cosine of 37. What's that? How? Yeah, theta is 37. Theta is your angle.
Oh, the angle is given is always theta?
Yes. Yep. So as I go into mode, please make sure that your calculator, make sure you're working in degrees. Take 11 and I divide it by the cosine of 37 and you get 13.77. Does it make sense that it is longer than 11? Yeah, it's the hypotenuse. Should be longer. You take 5 minutes and try to work through a couple of these problems right here, and we got to move on to the next part. Ready, set, go.
Wait, is there another side for you to find?
All right, so let's look at your homework again. We should be, no, that's calculus. We don't know how to do that yet. Yep, we would freak out. All right, so let's look at number 8. What's different about number 8? Somebody tell me. Looking for the angle. You see theta right here is for the opposite adjacent or hypotenuse. It's the opposite. Is 13 the opposite adjacent or hypotenuse? It's the adjacent. So if I have opposite and adjacent, do I use sine, cosine, or tangent? Tangent. So I set it up. Tangent of theta is equal to what? 4 over 13. So what's different now is that this is the variable we're trying to find, right? We're trying to find the theta. So what do? I'm only going to show this once, and it's pretty cool. If you had, say, 4 times x equal to 12, what would you do to solve? Divide by 4, because that's the inverse operation, right? If you had 4 plus x equal to 12, what would you do? Subtract 4. Suppose you had x to the 4th was equal to 12. What would you do? You take the 4th root. Suppose you had this. Suppose you had 4 to the x power is equal to 12. What would you do to both sides? Oh, did we already forget? Yep, you do the thing. Good. Log base 4. Remember that? So there's these inverse operations that just make things go away, right? And it kind of looks like magic, but it's what it is. So what we do is we do the inverse operation. So watch this. I do tangent inverse of both sides. And so what happens is those go away, leaving with theta is equal to whatever the tangent inverse of 4 over 13. So on our calculator, we just go like this. That's what this button means right here. If you turn it on, it doesn't mean 1 divided by tangent. It means inverse tangent. So we go second inverse tangent. You type in 4 divided by 13, and it comes up with an angle for you, 17.10 degrees. See, somebody, you guys are actually saying that's kind of cool, isn't it? It is pretty neat.
It isn't the same as cosecant?
No. go ahead. Take a minute. Try one or two of those problems as well. Go. I'm sorry, Janessa. Did you say something? Sorry, Janessa. I can't hear you. Oh, Janessa. All right, here we go. Notes back on. Let's finish this off. All right, example 1 and example 2. These are the last two we're going to do. Now you have entire triangles. The 90-degree angle you always label as C. The capital letters will be your angles. It doesn't matter which one you put as A or B. I'm going to put A up here and B down here. I see that B is going to be the smaller angle and A is going to be a little bit bigger, so I'm going to put them like that. The sides are the little letters. Side C goes across from angle C. Side B goes across from angle B. And side A goes across from angle A. We all good? Yo. Sure. Then 32 would go up there. All right, so I've got 32 degrees right there, and I've got side C is 8. This is 8. Great, let's solve it together. What is the easiest thing to figure out for this triangle right now? Yes. Why? Angles must add up to 180 degrees. Very good. So 180 minus 90 is 90, minus 32 is 58 degrees. Boom, done. So far you have 1 point out of 4 on this problem for the test. Let's get points 2 and 3. Gavin, would you like to use angle A or angle B? Angle A. Gavin would like to use angle A. He's going to use angle A, which is 58 degrees. Let's now label opposite, adjacent, and hypotenuse. Opposite or adjacent? This is opposite. This is hypotenuse. Because we are talking about 58 degrees. If we would have been using 32 degrees, then opposite and adjacent would be switched, right? So you have to decide which angle you're talking about, folks. You get choices. There's 6 different ways to set up the problem. You got to choose one. So he chooses 58 degrees. Now, he wants to find either A or B because he knows C. Gavin, would you like to find A or B? It's up to you. He wants to find A, all right? So that means he wants to find the opposite, and he's given the hypotenuse. He wants to find the opposite, and he's given the hypotenuse. Sine, cosine, or tangent? Sine. Sine of 58 degrees is the opposite, which is A, divided by 8. Cross multiply, and we get A is equal to 8 times the sine of 58. Take out my calculator. 8 sine of 58, and I get 6.78. What could I do to find side B? You could use the Pythagorean Theorem. Or you could set up cosine, couldn't you? You can do whatever you want. Pythagorean Theorem or cosine. I'll set up cosine. Cosine of 58 is equal to adjacent over hypotenuse. And Gavin is going to go ahead and do the Pythagorean Theorem. And Gavin, did you come up with 4.24? Does it make sense that 8 is the longest side? Because it's across from the biggest angle. Does it make sense that B is the smallest side? because it's across from the smallest angle. And then notice side A is in the middle because 58 degrees is in the middle. Question, Easton.
So determining this, what sides to use, like C and B, C can't. Okay, mind if I get up?
Go ahead.
Okay, so just so I'm clear, you can't for here. You cannot put B or C here.
You could put B here as long as angle B is there. Side A has to be across from angle A.
Okay.
Good?
Yep.
All right. All the problems on the left-hand side will follow like that. All the problems on the right-hand side will follow like this. What's different about this problem? You don't have the angles. Okay? So I'm going to call this angle A up there. I'm going to call this angle B down here. I know that side B is 12. I know that side A is 5. I've set up my triangle. Can somebody tell me how do I find which is the easiest thing to find right now?
Side A, little A.
Side
I have side A is 5.
Little C.
Side C, and you could use Pythagorean Theorem, right? Have we already established that this is a special right triangle? 5, 12, 13, thank you. That way I don't even need to go through the process. I recognize it. You might say that's cheating. Nope, you're going to get plenty of questions like that coming forward. Okay. Oh, you do that? I get you. I would hope that at least 50% of the class remembers that. All right, so now we have to make a choice. Marissa, would you like to find angle B or angle A? It's up to you. She wants to find angle B. So that means that I have the hypotenuse, which is 13. And I have the opposite side, which is 12, and I have the adjacent side, which is 5. I have all three sides, so any trig function is in play. Marissa, would you like to use sine, cosine, or tangent? It's up to you. She wants to use cosine. The cosine of angle B is equal to the adjacent divided by the hypotenuse. The adjacent is 5. The hypotenuse is 13. If you chose sine, you could do sine of B was equal to 12 over 13. You could use tangent of B is equal to 12 over 5. Or you could have done angle A and you would have come up with similar things as well. See what I'm saying? You'd have 6 options. Doesn't matter which one you try. We'll do the cosine one because that's what Marissa said, and she's extremely intelligent. Cosine inverse of 5 divided by 13, and I get this wonderful number of 67.38. Subtract from 180, and I get 22.62 degrees. All the ones on the right side will be set up so that you are missing an angle. You might say that you feel like there's 2 or 3 problems too many as you go through here. You need to learn to be quick with these folks, quick with them. We can't spend 10 minutes solving a right triangle. We have much more complicated things in trigonometry to get to as we move forward. But this will be a staple of what we need to do. Excellent, excellent job. You must be the best of the best.